Welcome to today's algebra tutorial by Caz Academy. In this tutorial, I'm going to show you 4 ways to solve quadratic equations by factoring. A polynomial equation in the form of ax squared plus bx plus c equals 0 is called a quadratic equation when a, b, and c are real numbers and the coefficient a does not equal 0. In today's tutorial, I'm going to show you 4 examples of how to solve these quadratic equations using factoring principles that you've learned in prior tutorials. Let's start with our first example. So with my first example, I have 3x squared minus 9x equals 0. So the first thing that you want to do is you want to look and see, is there any common factors that I can pull out to make this simpler. And we can see that both of these have a 3 and an x. So that means I can pull out a 3x, and that's going to leave me x and a negative 3. Now I'm going to set each of these to 0 so that I can solve them. Because using the zero product principle, that means that 3x, if that equals 0 and it's multiplied, then that's going to make my statement true, make that 0. Or if I have x minus 3, if that equation equals 0, then this product is going to equal 0. So I can set each of those parts equal to 0 and then solve for my variable. So I've got 3x equals 0, divide by 3 on both sides. That's going to give me x equals 0 as one of my solutions. And for my other one, I'm going to take that x, I want to move my 3 over to the other side. I do that by doing the opposite function, by adding 3 to both sides. That's going to give me, those are going to cancel out to make 0. So that's going to give me x plus 0 equals 3, which gives me x equals 3. Now we want to go ahead and plug those values back into my original equation to verify that they indeed are the correct solutions to my problem. So I'm going to go and I'm going to write my original problem and I'm going to test out each of those answers. So first I'm going to test out replacing x equals 0. So that would give me 3 times 0 squared minus 9 times 0 equals 0. Well, 0 squared is 0 times 3. That's going to be 0 minus 9 times 0 is 0 equals 0. So 0 minus 0 equals 0. This is a true statement. So that tells me that x equals 0 is indeed a solution to the problem of 3x squared minus 9x equals 0. Now I'm going to test my second value, x equals 3. I'm going to take my same original equation, and then this time anywhere I have an x, I'm going to replace that with a 3. And I'm going to see if I also get a true statement. 3 squared is 9. 9 times 3 is 27. 9 times 3 is 27 equals 0. Once again, 27 minus 27 is going to equal 0. That's going to give me 0 equals 0, which is also a true statement. So that tells me that indeed that x equals 0 and x equals 3 are true answers for my problem. So this was my original equation. And then my final answer would be 0, 3 to show the two possible answers for x. In my second problem, let's say that I am given x squared minus 16 equals 0. And I recognize that this looks like it can be the difference of two squares, because 16, I can make that into a perfect square of 4 squared. So that's going to give me x squared minus 4 squared equals 0. And then I can change that into break that down into two binomials using the difference of two squares. So that's going to be x minus 4 times x plus 4, set that equal to 0. And once again, using the zero product property, I'm going to set my first equation equal to 0 and solve for x, and set the second equation equal to 0 and solve for x. So I want to move that 4 over to the other side. I do that by doing the opposite to both sides. Negative 4 plus positive 4, that's going to equal 0. 0 plus 4 is a positive 4, so that gives me one solution as x equals 4. And then for my second one, once again, I want to get that 4 over to the other side, so I'm going to move that by doing the opposite sign. So I'm going to subtract 4 from both sides. That's cancel those 4s to give that 0. And that's going to give me x equals a negative 4 as my other solution. So once again, now I want to do the checking. So I'm going to go back to my original equation, and I'm going to plug in each of these solutions to see if they are indeed correct. So I'm going to start with my original equation. I'm going to start with my 4. So if I have 4 squared minus 16, I want to know if that's really going to equal 0. 4 squared is 16. 16 minus 16 does indeed equal 0. So that's going to make my first value of x equal 4. That's going to be true. Now let's do the same thing with my second value. My second value is a negative 4. And my x is a negative 4, so you want to pay attention if whether or not the negative is on the outside or the inside of the parentheses when you square. Because my x equals a negative 4, that negative is on the inside. So that is the same as a negative 4 times a negative 4. And we want to see if that's going to equal 0. I have a negative and a negative. That's going to make that a positive. 4 times 4 is going to be 16. So once again, I have a positive 16 minus 16, which equals 0. So that's going to be 0 equals 0. And that means our other solution is also true. So that means my final answer is going to be minus 4 and 4. In our third example, let's say we are given x squared minus 2x minus 15 equals 0. So with this equation, we notice that we have a trinomial where a equals 1. So we have an imaginary 1 right there, here. So this is a trinomial where a equals 1. And I have a tutorial video on how to factor trinomials when a equals 1. And the way that we do that is we need to find a number that multiplies. We need to find two numbers that multiply to equal 15, and when they add up together, they're going to equal that 2. So the way that we break that down is we take our 15, which is our c, because this is our ax squared, our bx, and our c. So you're going to take your c and you're going to factor it and write down all of the numbers that when you multiply them together are going to give you 15, and then you're going to look to see if I multiply them what's going to give me a negative 2. So I have 1 and 15, that will give me 15, and 3 and 5. And I notice I've got a negative here, so one of these are going to be positive and one of them is going to be negative in order to get those signs. If I have a negative 5 and a positive 3, if I add those two together, negative 5 plus a positive 3, that's going to give me a negative 2. So that tells me that these are the factors that I'm going to want to use in order to get that middle number. So now I can break that up into that trinomial to a binomial. So I'm going to put x here, my x. That's going to be x when I multiply my two x's. And now I'm going to use those factors that I just pulled out. So I'm going to have a 3, and I'm going to make that one positive, and I'm going to make my 5 negative, and I'm going to set that to 0. Now I can double check that using the FOIL method to make sure that those are correct. So if I take x times x, that's going to give me x squared. If I take x times a minus 5, and if I take that's my outside and my inside, and my two outsides, 3 times 5, that's going to give me x squared minus 5x plus 3x, so a minus 2x, 3 times 5 negative minus 15. So that tells me that I have factored that trinomial into a binomial and that my numbers are correct. So now what I want to do is I want to solve for that x variable using the zero product principle. So I'm going to set each of those equal to 0. So I'm going to take x plus 3 and set that equal to 0, and I'm going to take my x minus 5 and set that equal to 0. So that's each of these, that one, and that one, and now I'm going to solve for my x. So I want 3 to go on the other side. I'm going to subtract 3 from both sides. That'll make these 3's cancel out and give me x equals a minus 3. And then on this side, I want that 5 to go to the other side, so I'm going to add 5 to both sides. That's going to make these 5's cancel out, and that's going to give me x equals a positive 5. So those are my two values, and then once again to go back and I need to check them, plug them back into my original equation and check to make sure that those are correct. So I have my original problem was x squared minus 2x minus 15 equals 0. And now I'm going to plug in each of those values to make sure that they are true statements. So let's start with our first one, x equals a minus 3. So everywhere I have a minus 3, I'm going to plug, everywhere I have an x, I'm going to plug in a minus 3. And I'm going to see if when I add everything together, if that's going to give me 0. So that's going to give me a minus 3 squared, which is going to give me a 9. So remember, that's a negative 3 times a negative 3. Negative times a negative is going to make a positive. Then once again, I have a negative 2 times a negative 3. So whenever you have a negative, you can also think of that as a plus the negative, or a plus a negative 1. So I've got a negative times a negative. Once again, that's going to make a positive. 2 times 3 is 6. And then I have my minus 15. And if I take 9 plus 6, that's a positive 15 minus 15, which is going to equal 0. So that means that my first value of x equals minus 3, that's a true statement. Now let's try the x equals 5. We're going to do the same thing. I'm going to take that 5, put it into my x squared minus 2, place the x with a 5 minus 15, set it equal to 0. 5 times 5 is 25, minus 2 times 5, which is 10, minus 15 equals 0. Once again, I've got 25 minus 25, which is going to give me 0 equals 0. So this is also a true statement. So that means that my final answer is going to be minus 3 and a positive 5. In our last example, let's say they give us the problem 3 minus 10w equals a negative 8w squared. So the first thing that we recognize is that we're going to need to move these numbers around because we want it in the form of x squared plus x plus c equals 0. So let's identify each of our variables. So this is our c, this is our bx, and this is our ax squared. So the first thing I'm going to do is I am going to add my 8w squared to both sides because I want to move this over to the left. That's going to cancel that out to equal 0. And on this side, I'm going to have 8w squared plus 3 minus 10w equals 0. So it's almost correct. Now we just need to swap these so that everything's in the correct order. So now I have 8w squared minus 10w plus 3 equals 0. So now my formula is in the correct format, or my polynomial expression is now in the formula of a quadratic expression. So now the next thing that I need to do is I can recognize that I have a trinomial where a is greater than 1. And I want to factor that in order to get a binomial. And I have a tutorial, I have a separate tutorial on how to factor trinomials when a is greater than 1. And a is this 8. And so the way that we do that is we use the AC method. So I'm going to take the A, which is an 8, and the C, which is the 3, multiply those together to get 24, and then I'm going to factor the product of AC. And what I'm looking for is I'm looking for two numbers that when they multiply together, they're going to give me the product of 24, and when I add them together, they're going to give me that B of a minus 10. So 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. I know that 4 plus 6 equals 10, so that is going to be my set of factors. Now in my problem, I have a negative B and a positive C. So that tells me if I make both of those negative, negative times a negative is going to give me a positive 24. And when I add two negatives together, that's going to give me a negative. So now I'm going to rewrite my equation as 8w squared. And then instead of this negative 10w, I'm going to write the sum of minus 4 and minus 6. So I'm replacing the negative 10, breaking it into two parts. So that's going to be minus 4w minus 6w plus 3 equals 0. Now I need to group these and get them into a binomials. So I'm going to group those two together, and I'm going to group those two together, and then what I'm going to look for is there any common factors that I can pull out. So with this first one, I can see that both of them have a 4 and a w. So I'm going to pull out a 4 and a w, and that's going to leave me with 2w minus 1. Now with my second equation, I can see that both of them have a 3, so I'm going to pull out a 3, and that's going to leave me a negative 2w plus 1. Now I want this in the parentheses to be the same, and I notice that there's only a small difference. There's a difference in a sign. So what I can do is I can pull that negative out in front of the 3, make that 2 positive and negative. So now I have 4w minus 1 times a negative 3 times 2w minus 1. Because what we want is we want those numbers in parentheses to be the same, because that means that I can group them. And then what I'm going to do is I'm going to pair these two numbers that I pulled out, group those two together, 4w minus 3, and then I can multiply that by 2w minus 1, the numbers that were in the parentheses, and set that to 0. Now I can use the zero product rule to solve for my w's. So I'm going to take my 4w minus 3 equals, and my 2w minus 1 equals 0, solve for 0. I want that 3 on the other side, so I'm going to add 3 to both sides. That's going to cancel that out. That's going to give me 4w equals 3. Divide both sides by 4. That's going to cancel that out. And that's going to leave me with w equals 3/4. So that's my first solution. For my second one, I have 2w minus 1. I want to move that 1 over to the other side, so I'm going to add 1 to both sides. That's cancel out equal. Give me 2w equals 1, divide both sides by 2, and that's going to leave me with w equals 1/2. So w equals 1/2 is my second solution. And then, as always, now that I have my 2 solutions, I'm going to go back and I'm going to double check that those truly are correct answers. So I'm going to start with my original equation, 8w squared minus 10w plus 3 equals 0. So notice that I'm using this equation right here, which is just a modified version. You can use the original equation, but I think it's a little bit easier if you use the equation where we have arranged or moved our numbers and variables around in order to be in the quadratic equation formula. So now I'm going to plug in. I'm going to start with my w equals 3/4. So I'm going to in every w, I'm going to put in my 3/4. And then I'm going to do some simplification rather than multiply these through. I can see that I can simplify. So if I times 3/4 times 3/4, I know that 8 divided by 4 is going to leave me with 2, and then I can take divided. It's going to leave 2 times. So that's going to give me 3 times 3 divided by 2. So 3 times 3 is 9 divided by 2. Then I'm going to do the same thing for this other, my second equation. I know that 10 and 4 can both be divided by 2. So that's going to leave me. So that's going to give me a minus 5 times 3 over 2. Minus 5 is 3. That's going to give me 15 over 2. And then I still have plus. 9 halves minus 15 halves is going to be a negative 6 halves plus 3. And that can simplify to minus 3 plus 3 equals 0, which is 0 equals 0. And that is true. So with this problem, you'll notice that I did simplification along the way so that I didn't have to have a bunch of big, messy fractions. So that's something that you can do. You want to remember that when you have multiplication and fractions, that's like multiplication and division happening at the same time. If you see that you can pull out factors and cancel numbers, you've got numbers on the top and numbers on the bottom that are the same, those can divide out, and that will help to make your numbers that you're multiplying with simpler. So we just proved w equals 3/4 is one of our solutions. Let's do the same thing for w equals 1/2. So now we want to test w equals 1/2. So we're going to our original equation, So that was 8w squared minus 10w plus 3 equals 0. And we're going to replace all of our w's with 1/2. So 8 times 1/2 squared minus 10 times 1/2 plus 3 equals 0. So once again, we've got 8 times 1/2. 1/2 squared is 1/4 minus 10 over 10 times 1/2. Those divided by 2. So 10 divided by 2 is going to give me a 5. 4 is going to give me a 2. So I've got 2 minus 5 plus 3 equals 0. So that's 0 equals 0. And when this is also true, stating that dimensions are true, my final answer will be 1/2, 3/4. So there you go. Examples showing you how to solve quadratic equations by factoring. Thanks for watching. Be sure to like and subscribe to get the latest videos by Caz Academy, and be sure to check out the links in the description for additional supports and resources.